Hi everyone. Today I'll be talking about regexes, how they work, and when you should use them. The word regex is short for regular expression. Regular here refers to a certain kind of formal theoretical construct called a regular language. Now, as much as I'd love to do it, I'm going to avoid expounding on formal language theory at this point. TLDR, regular means you can use a so-called railroad diagram, like this one, to determine whether some given text matches the pattern or not. This diagram represents this regular expression. But let's forget that for a moment. To determine whether some text is considered to match the regex, you imagine a train starting on the left, moving to the right, and recording all the letters it passes. It might pass the P, then the E, then the T, and so one of the words matched by this diagram is pet. Or the train could follow the bottom track, passing the P, then the A, then the R, and finally the T, matching the word part. It could also use this side track to bypass the letter R, matching the word pat. Now you might think this sidetrack allows the train to loop back and pass the R again, but unless the diagram says otherwise, all tracks are one-way streets pointing to the right, so P-A-R-R-T does not match. Likewise, the train can't pass the E, then back up and pass the A and the T, so Pete is not matched. The train must start at the left circle, it can't start at the A and spell art. And it must end at the right circle, so it can't match the word par. That means that there are only 3 possible words matched by this railroad diagram, and all other text is rejected. So if you wanted to look for only the words pet, part, and pat, then this regular expression would do the job perfectly. The thing that's special about a regular language is that all you need to make it work is the railroad diagram. There's no need for any other bookkeeping or backtracking. This makes them efficient and simple, running in a single pass over the given text, processing each letter just once. And regular expressions are a handy way to describe regular languages, which is what makes them so popular. Here's one that matches all valid Canadian postal codes, matching letter, number, letter, number, letter, number. Or this one, which matches IP addresses. Or this one, which matches ISO standard date strings. But now I'm getting a little ahead of myself. What do the symbols in regular expressions represent? Well, most characters just represent themselves, so the sequence BAG matches only the single string bag. You can make branches in the railroad diagram with a vertical bar symbol, so this matches brag and big. It does not match brag vertical bar big because the vertical bar is special. Now this particular example is a little redundant because we had to repeat the B and G parts. We can use parentheses to make the branching a little more specific, like this. Now, if you didn't know the parentheses were special, you might think this pattern would match these 2 strings, but it doesn't. Well, unless you're using a POSIX basic regular expression, or BRE, in which case parentheses are not special, so this matches the 2 strings B parenthesis RA and I parenthesis G. Different regex systems sometimes have different rules. If you want parentheses to be special in a BRE, you need to add a backslash, so you'd represent the pattern like this. But in Java, Python, and JavaScript, this has the exact opposite effect. Parentheses are special unless you add a backslash, in which case they are taken literally. Well, nobody uses BREs, right? Let's continue. You can make something optional by using the question mark symbol. So this matches bag and bang. If you want to allow for some pattern to repeat, you can use the plus symbol, which allows one or more of the preceding pattern. So this matches big, or BIIG, or a B followed by any number of I's followed by a G. If you also want to allow 0 repeats of a pattern, you can use the star symbol instead. BI star G matches all the same patterns as before, plus BG with no I's. So you could combine these symbols and write BI star G as BI plus question mark G, because an optional sequence of 1 or more is the same as saying a sequence of 0 or more. Pretty powerful. Wait, actually, no. According to the Java documentation, plus question mark is a special operator that makes the match reluctant, meaning it matches as little as possible. Better stick with the star, I guess. Oh, and the docs also say that plus plus becomes possessive. So if you look up how the matcher works, you find that if the first match attempt fails, then it tries again, repeating the process until a match is found. Wait, isn't that backtracking? Here we were thinking the whole point of regular expressions was that they ran in a single pass with no bookkeeping and no backtracking. Okay, well it turns out that modern so-called regular expressions actually include extra features that increase their matching power to the point that they no longer are truly regular expressions, and they require more complex and slower algorithms to execute. But if they're not efficient, at least they're clear and concise, right? So let's put together what we've learned so far to make something useful. Suppose we want to look for the three-letter abbreviation for the month of March, MAR, with or without a trailing period. We could do that with a regular expression like this, except that isn't right because the period is a special symbol that matches any character. So this would also match Mark and Mars, but not quite any character. It won't match a line terminator, usually, depending on the system you're using and how you've configured it. Anyway, what we need to use is this regex with a backslash to tame that period symbol. Except regexes are case sensitive usually, and we'd like this one to be case insensitive. How do we do that? Well, sometimes you can instruct the system to do a case insensitive match using special options specified outside of the regex itself. These vary from system to system. If we want to be sure and we want to specify it in the regex itself, we'd better write it like this, using these special square bracket symbols to indicate the allowed characters at each position. But this will also match the letters MAR if they appear inside other words like remarkable. Well, Java regexes have a special symbol to represent the imaginary character at the start and end of every word, called a word boundary. It's represented by \B. So let's put one of these on each end. Our pattern would now be this. No, wait, that's not right. If the period is followed by something like a colon, then that's not a word boundary, and our pattern won't match because it needs a word boundary immediately after the period. As you can see, defining the dividing line between what is and isn't matched by a given regular expression is a challenge. We actually want the word boundary before the period like this. All right, we have our regex. It seems like quite a mouthful given how simple our requirements were, but we're not done yet. Now we need to write this in our Java code. So we put it in quotes. But in Java, the \B sequence in a string does not mean a backslash followed by a B, which would represent a word boundary. It means a backspace character. We need to tell Java that we actually want a backslash before that B, so we need to protect that backslash from Java with another backslash, making it \B. In fact, we need to escape all the backslashes with more backslashes, so we type this. And you're in for an adventure if you actually need to match some backslashes. On Windows, for instance, file paths can specify a server by starting with 2 backslashes, like this. The regex to match this literal string would need to be this, with all the backslashes protected by backslashes. To type this in Java, you need to protect those backslashes with more backslashes, giving this. Backslashes tend to multiply, and there's no way to tell whether you have the right number without just counting them all. In fact, the string I just gave you contains an error. Good luck spotting that extra backslash in a code review. And furthermore, I'm practically certain there's another regex example I've given in this video with an unintentional error. How do I know this? Because of what I modestly refer to as Doyle's theorem. All useful regexes are trivial or wrong or both. The proof is left as an exercise for the reader. The corollary is every non-trivial regex in production has a bug. Remember this one, which matches all valid Canadian postal codes? It doesn't permit the customary space character in the middle. Or this one, which matches IP addresses? We forgot the backslash in front of the dot, so it actually matches any character between the numbers, even other numbers. Or how about this one, which matches ISO standard date strings? We know it must have a bug, thanks to Doyle's theorem, though I haven't bothered to find one. You're welcome to look for the bug yourself. If you look hard enough, you are sure to find it. Regexes are obtuse, unreadable chunks of code whose meaning varies from system to system, and they're based on an esoteric theory that most users are not even really aware of, whose benefits do not even materialize because modern systems have extended them beyond the boundaries where they perform well. They frequently match text that they shouldn't, or fail to match text that they should, and they're not particularly efficient at it. So what are regexes good for? Well, there's nothing wrong with using regexes in an interactive setting where they're composed on the fly and where the outputs are inspected by a human who can deal with any matching errors. If you can spot false matches and you can tolerate missing a few matches, regexes can be pretty handy. So go ahead and use them in your editor while writing code, where regex mistakes will probably be caught by the compiler or unit tests. What you want to avoid is using regexes in any scenario where the software runs unattended, where matching errors lead to incorrect behavior. Usually the problem you're trying to solve is either simple enough that you don't need regexes, or complex enough that you need a proper parser. It's very, very rare that regular expressions are the right tool, and even when they are, you are sure to use them wrong because everyone uses them wrong. Because there are two kinds of programmers, those who are aware that they can't write regexes and those who aren't. And after all this, if you insist on using them in your code, you need to unit test them heavily and thoroughly with both matching and non-matching cases. But really, just don't do it. Thanks for watching.